Good morning.
Good morning.
So this talk was prompted by a conversation that I had with my client when I was trying to describe to them what all Azure ML was. And I figured that I could just give them a link and then I wouldn't have to say anything. And then I found out there really wasn't one that was able to really kind of encapsulate everything that Microsoft could possibly and does sometimes call Azure ML. And so for the purpose of this discussion, Azure ML is anything that's machine learning that you can put in Azure, because that's how their marketing people do it. And if it fits that definition, I'm going to talk about it today, which is a lot of products. This is the first time you're going to see this slide, and you'll be sick and tired of it by the end of the session, but now it's new. All right, past has got a whole bunch of stuff. And my name is Ginger Grant. I have a blog at Desert Isle SQL. I am an author. I wrote the now retired Azure Machine Learning Test Prep book, which doesn't matter anymore because I replaced it. I'm also a consultant. I am an instructor for DataCamp, which is a online training service that focuses on machine learning. I'm also a data platform MVP and a Microsoft certified trainer. All right, so what we're going to talk about today is we're going to talk about anything that's Azure ML. And Microsoft calls everything Azure ML, so you'll be seeing everything that they call that. And we're going to call, what machine learning and the Azure Machine Learning Service. They actually don't call it the service anymore, but you may see some documentation that still refers to it as that. And then we're going to talk about other ways of implementing machine learning in Azure. So if you look at what Microsoft says, though, for Azure ML, they have a whole bunch of options. And I know you can't really see them all up there, but they just, they have a whole bunch of little boxes, and like, that's ML, that's ML, that's ML. But really, it comes down to this. They've got the Azure Machine Learning Service, which they are now calling Azure Machine Learning, most places. Azure Machine Learning Studio. And this is the product that has been around the longest. Then there's Azure Machine Learning Notebooks, automated machine learning for Visual Studio Code, Microsoft ML Server, Data Science Virtual Machine, Databricks, and Cognitive Services. So all of this, Microsoft might, at some point in time, call Azure ML. One thing that's not up there that you might notice, and you're like, hey, what happened to Azure Workbench? That's got to be the shortest product that Microsoft ever had available. I think it was around for 4 months before it was retired. And everything that was cool inside of it, they moved to other products. So the tech lives on, but the product is dead. So, but Azure Machine Learning exists in a whole bunch of other places. As a matter of fact, there is now a Visual Studio Code extension called Azure Machine Learning and a Python SDK. And there's a bunch of pipelines for DevOps. And they have one also that they call Machine Learning Ops. And then there's the visual interface for creating machine learning. So with how all of this kicks off, though, is you need to create a machine learning workspace. This is kind of the center point for a majority of these products, except for the SDKs, which you can just download. And this is where Microsoft hopes that you will run and process your machine learning items. Now, let's say that you've got a data scientist who is busy doing all of their machine learning components on-prem. That's fine. You can still encapsulate it and move it to the cloud. The idea that they created this workspace was they were trying to solve a problem. And that problem is that there's a whole bunch of machine learning modules that are being run in corporations today, and people don't know who created them, how long they've been there, how many times they're run, what the average time that they're run, and what necessarily they do. And so the idea was that the machine learning workspace would be a place to do a number of things, but the first thing that they were really interested in doing is centralizing the processing of any machine learning that you happen to have created. One of the things that the workspace does is it separates compute from code. And what this means is that if you have a process that you say written in R and it takes forever, you can just change the compute that you're using to whatever your checkbook can afford, and it'll run faster. So compute is completely separate from the code. It's got what they call experiment management. The idea being is that you can continually test your modules over time to see if they're still working appropriately. And they also have something to try to introduce machine learning to people who are not that familiar with machine learning, and that's called automated ML. And automated ML creates machine learning by going through a couple of steps and questions, and it creates anomaly detection, regression, and cluster analysis. So it does that out of the box, so you don't really even have to know what you're doing. You can put up a data set there, and it'll create the experiment for you. It's got different data stores that you can basically allocate to machine learning so that you have a record of what data source that you're using to create your experiments. And also images so that you can have different versions running. And then handles deployment. So part of the handling deployment, they have a component within the Azure Machine Learning Workspace called ML Ops. And the idea with ML Ops is it provides an environment that is going to ensure that you can do the same thing over and over again. I worked at a client not too long ago, and the data scientist said, yep, I'm all done. Here's this machine learning component that I have created, and this was to analyze insurance rates. And they said, well, just go run it. And the IT department said, well, what's your data source? Oh, I created it. That's great. Where'd you get it from? Yeah, somebody sent me a bunch of files. And you can just imagine how that deployment went badly in one word. But the idea is you need to have results that you can reproduce because you have known data sets. And you know what you're running, and you know what your output is. And so this will allow you to register and track models to capture audit data so that you can use that to determine if your model is still good over time. You can also deploy your models in Docker images, so you can literally put them anywhere. And one thing that was mentioned in the keynote, you can also convert the model into Onyx to improve performance. And we'll talk a little bit more about how you can do Onyx and why you should care, in addition to what they talked about in the keynote. But one thing that they've also created is the Azure Machine Learning SDK. And this is not actually Azure. This is a component that you would use to write code, but they call it Azure Machine Learning. And this is designed to incorporate the steps that you use and log the metrics in training. And you can measure success outside of the environment, and this is what kicks off the ML Ops process. So within Azure Machine Learning, they have what they call pipelines. And as you may know, if you do a lot with machine learning, you don't need to use Azure Machine Learning to kick off a pipeline. ADF does that just fine. And there is no reason that you actually need to do anything but use ADF if you've got a component that you use to do some machine learning analysis and you have that kicked off as part of your pipeline. But of course, there is an Azure Machine Learning pipeline as well. And then there are Azure pipelines. And the difference between the machine learning pipelines and the Azure pipelines is that the Azure pipelines are designed to be open source and to use Docker containers. So the way that these pipelines work and the way that Microsoft envisions that machine learning components will work in the future is using the Open Neural Network Exchange. And the idea with this is it's an open source element that Microsoft has contributed to, and it allows you to encapsulate your code so that your code can run anywhere. So if you want your code to run on Linux, fine. If you deploy with Onyx, you can. You can run it on Microsoft's cloud. You can run it on Amazon's cloud because they support it. So that way you can use, encapsulate TensorFlow or whatever you want to. But if you encapsulate within Onyx, then you can run it anywhere. And one of the things that it does is it's designed to perform very well, and it will integrate with various accelerators that use things like NVIDIA GPUs, which is commonly used in machine learning to improve performance. So the idea with deployment is you just create your machine learning component any way you want to. These are some of the products that they have out there. And then you, using the SDK, you compile it into an Onyx model, and then you can deploy that anywhere. So if you, and of course, Microsoft hopes you do this in the cloud, but you don't have to. But they do call this Azure Machine Learning as well, just to make that perfectly clear. But this is kind of the way that they consider that things will be going in the future. You can write your machine learning wherever you want to, but you can choose to deploy it, and they're making it really easy to deploy it in Azure, even if you say you wrote it in Linux using R on some other machine. But they still want you to be able to deploy it within Azure with a minimal amount of work. So deployment with Azure Machine Learning is the idea is you can deploy to an Azure container instance or a web instance. So you can use the ACI Docker or Kubernetes, and then you can use field programmable gate arrays and use those with any of those things for deployment. They have a notebook virtual machine as well, which you can use to deploy that. And then they have an Azure App Service that you can deploy to as well. So of course, Microsoft has a notebook virtual machine because everybody has a Jupyter Notebooks, so they have to have it incorporated in the Azure Machine Learning product as well. But there is also, you can also use notebooks.azure.com as well to create notebooks. Everybody else has a free notebook service, so Microsoft has not one, but two. Places that you can do that. So you can create the automated machine learning with using notebooks as well. And it contains Python along with a number of other languages that are supported with Jupyter Notebooks. So one thing that I wanted to talk about in a little bit more detail is automated machine learning. And automated machine learning is how Microsoft is trying to democratize machine learning so that more people can create machine learning components. The little asterisk there wouldn't have been there 3 weeks ago because it wasn't true then, but it is now. They have created a new pricing tier called Enterprise Edition. And if you do not get the Enterprise Edition of a Workspace, then you do not have automated machine learning. It is also in preview right now, which means that you don't get charged for that Enterprise Workspace. So if you want to play around with it, do it now before they release it because you don't get charged for it at this point in time. The difference between an Enterprise license and a standard license is you are charged for hour of use. It's 7 cents, but it can go up depending on, that's just a minimal charge for the fact that it's up and running, that it'll be 7 cents an hour when it is running. The real charge when you're doing anything with machine learning has to do with your compute resources, and you control that. So if you don't mind waiting long periods of time, it'll be much cheaper. If you want really fast stuff, that'll cost you. And if you want to be cheap and then you realize, I just can't wait this long, you can change it out, which is kind of nice about separating the compute. You can always change it. So it's designed to, for automated machine learning, you pick an algorithm classification to do an algorithm, so either regression, anomaly, or classification. Those are the three that they support. You specify the source and the format of the data that you want to analyze. You configure your compute. You construct the parameters. Actually, it'll construct them for you. And then you submit a training run. And if you like the results, you can deploy it. So enough talk about what you can do with Azure Machine Learning Service. I'm going to go ahead and show you how it works. So I'm going to do the quote-unquote what I call the cooking school version of creating a resource because it does take 15 minutes, and I'm sure you all have better things to do than to watch the little thing spin while it does it. But the first step to using Microsoft's Azure Machine Learning is to create a workspace. So I'm going to go ahead and do that. And it's relatively simple. You create a workspace, give it a name. And a subscription, a resource group. You can select an existing or create a new one. And select a location. Like all Azure products, you need to make sure that your location is where you have your data. Otherwise, you're going to get charged when things go by. And then the Workspace Edition. And this is relatively new, and you have Basic and you have Enterprise. So the Basic version is cheaper, but it doesn't have automated ML, and the Enterprise does. The pricing details, I'll go ahead and click on this. But this is how you can find out the charges for it. And you can see there's quite a big difference between Basic and Enterprise in terms of the features. And in the pricing, it tells you that it's 7 cents an hour per core for ML surcharge, so versus Basic. So not only is the feature list quite different, but so is the pricing. And I just clicked on that by going to Workspace Edition, full pricing details, so that you can do that. But the other thing that I will say is since this is in preview, they're not the charges right now. Will not hit you for Enterprise, because I believe the Enterprise pricing tier is 4 weeks old. And yes, I do want to discard this. So we're going to go to my existing machine learning workspace. And this is where Microsoft anticipates that I will be my container, my resource group, if you will, for all of my Azure machine learning components. I will launch the new Machine Learning Studio. Oh, by the way, this is a new name. This was not called this 3 weeks ago. And so maybe this name will stick, I don't know. But the new Azure Machine Learning Studio, we'll look at that after we look at the rest of the components, because I've had some issues with it today, and I want to make sure I can show you how it works. So what we have listed within my workspace is I have different experiments. So these are all the experiments that I have that are incorporated within my workspace. So I have binary classification, some regressing, data set analysis. And it shows when they were created, and then later on we'll see how they were run. So if I go ahead and click on this one, you see that it was run once, and when it ran, it took about, the duration in seconds was over 1,000 seconds. So you get an idea of how long it ran. And of course, this accumulates over time so that you can see how all of your experiments performed. So let's see if I look at. And what I find really interesting when I look at this is that there's a lot of variation in how long it took to run. And this is just sort of an example of some different times it takes to run. And you can see that it completed, when it was run, and then the tags associated with it, and if it ever failed. So what's great about this is that you have a record over time regarding your machine learning components when you're running them. So, and if you have them within a pipeline, this information is still included within the workspace. You also have this is considered an Azure machine learning pipeline. And it's not showing my pipeline right now. It only wants to show it in the studio. I don't know why. Compute is all of the resources that I have created to do all of my resources for machine learning. So I've got you'll see that I've got different virtual machine sizes here. Let me make this a little bigger. So I've got standard D3, standard DS2, standard V2. And of course, every single one of these has different pricing, different pricing associated with it based on the number of cores that I'm choosing to use. So you could also look at, creating training clusters And I don't have any inference clusters or attached compute, but I could have those as well. So these are all of the compute that I am using to run any and all experiments that I might have. And if I wanted to go faster, if I wanted to create a new VM, I would just go ahead and give it a name. And then I could do, that's weird. And these are all of the different computes available to you. And if you want to go all in for the biggest one ever, you probably are going to want to go look at pricing to see how much this is going to run you. But just keep that in mind. And these are all running right now. If I wish to save resources, and I'm not doing a presentation, I would probably stop some of these if I wasn't running it, so that I didn't have to continually pay for the compute. I have a couple of models that I have created that are stored within here as well. And these models are ones that have been deployed within Azure Machine Learning. I've got images, and these are the images of the different models that I have. So this way, let's say that someone provides a new update or changes a model, and things go badly. You can go back to the previous image. So you've got kind of a built-in ability to go back. I have different deployment options available here as well. And so I've got simple deployment using ACI, so that this is deployed as part of the pipeline, which it didn't show you for whatever reason. And I have different activities listed here. And then you can also see, these are this is everything that I've done. So you can see I did a couple of, I've done some runs. And on everything that's ever happened. So you can get a look to see what people are doing. And since everybody's working remote, this is kind of a great way for managers to see how often people are doing work as well. So it can also be used as a monitoring tool. And notice that also, I deleted this. So I think this is kind of an interesting name for compute provision, because what I did is I made it go away. And so that's not the most intuitive name in the world, because that's gone. Usage and quotas is not what I think of when I think of usage and quotas. What this is really telling you is how much I'm currently using of what I have allocated. So you could see if you have a lot of your compute that is currently utilized, maybe you want to adjust it. Or in my case, if I'm only using 16% of compute, maybe I can drop it. So it gives you an ongoing picture of what's going on in your environment. Now, I did wait for this for later because I wanted to make sure that it worked. But I'm going to go ahead and launch the new interface that they're working on. And this was updated last week, and it has different components even then. So this is the new interface that they're pushing toward the machine learning components. It's going to replace what I just showed you. So it contains notebooks so that I could actually take a look at all of the notebooks that I have. But it doesn't work, unfortunately. There is a way around it, but I talked to Microsoft today, and they're working on getting that fixed. So for automated ML, what this shows you is the ability to create a new automated machine learning solution. So I'm going to go ahead and create a new one. And with that, what I can do is I can either upload a data set or use a data set that I have that's existing and take a look at what I can do to do some analysis with this. So I have a data set called airplane crash. And with airplane crash, it looks at a whole bunch of information and how many people died in the plane crash. So what I can do too is I can look at some different statistics on the sample data, and it shows me like how many people died on average, how many people were aboard, and how many were died on the ground. So I've got like different information that it automatically gave me statistics for. Then what I can do is I can go ahead and click Next if I want to do some automated machine learning on this particular data set. And it can say, create a new classification, or you can select one. So I'm going to create a new one. So I'm going to call this, crash analysis. And then I'm going to say, okay, it wants to know what I'm looking for. And I'm looking to try to figure out if I can figure out how many people are dead, because I'm morbid that way. And this is where I pick my compute. So I can pick whatever I want to when it comes to resources here. And oh, by the way, if this is totally slow, I can go back and pick a different one. And again, I'm not doing anything. This is an automated process that I'm creating for it to analyze data for me. So I'm going to go ahead and say Next. And then it says, what are you trying to do? And it says, and it determined that I probably want to do classification given what my data does. And then I can go ahead and there's a deep learning available that I could add for this, but for what I'm doing, I don't think that's very necessary. And then I can say Finish, and it's telling me that it's created an automated machine learning analysis of my data. So what the idea is with this kind of interface that more people could analyze their data kind of on the fly. And provide that kind of analysis. And I will say that this is going to be a while, so we'll kind of look at some other things that are contained within here as well. The other thing that they have is something called a designer, which was called a visual interface 2 weeks ago. So what they have is they have a blank space for you to create it, and then there's also some samples. So I'm just going to go ahead and take a look at some samples here to give you an idea of what the interface looks like. So it tells me that I will need to select a compute target, so I'm going to go ahead and do that. So for everything I do, I have to make sure that I have a compute target. And what this is a visual interface that does various different machine learning components. So this is the data. This is taking a look at the columns in the data set. This is a cleaning process for the data, splitting the data into test and train, and then running a boosted tree regression against it. And it's also going to, as well, look at decision forests. We're going to compare two algorithms and then evaluate the two of them. Now, for those of you who are familiar with another product that we'll take a look at later, this is all done through what Microsoft calls in Power BI, clicky, draggy, draggy. So the algorithms are listed on the side, so I can just drag them and drop them into my solution here and pick the ones that they have available to me. Now the idea is this is the automated stuff. This probably isn't what somebody who's really familiar with machine learning would do, but again, this is providing a tool that allows people to get started with doing it. And then I can go ahead and say run, and it's going to take a look at how well this is going to do. So what did I call this one? Let me get out of that. I don't remember what I called it. Okay, it's called sample 2. So I'm going to go say run. And this is a new experiment. And I'm just going to call this sample 2. Come on. And it tells me where my compute is, and I'm going to go ahead and say run. And it's going to run this particular machine learning solution. So you can see it'll have like little green checks. So so this is just another component, and they call all of this Azure Machine Learning. So gives you an idea of the different variety of things that are contained within it. When it is done, I will be able to evaluate the performance of two algorithms by looking here, which will allow me to see the results of 2 of them. I don't know how long this is going to take, though. This is one of those things that takes a long time or takes no time at all. It just depends on the weather or whatever. I don't know what. So this is what Microsoft is now promoting as Azure Machine Learning, and contains all of the components you would need to not only run something yourself that you don't, if you don't know what you're doing, but encapsulate something that is written by somebody else in another way using Onyx. So let's take a look at some other things that are also called, that Microsoft also considers part of Azure Machine Learning. Wow, and it'll come back when this is done running. For those of you who have messed around with Azure before, you'll also notice that there is something called Azure Machine Learning Studio. Azure Machine Learning Studio, in my mind, is one of Microsoft's best Azure products that they've ever released, because it is the only product that is 100% free. They don't even ask for a credit card. Needless to say, they're not really promoting this one, because the idea with this particular product is that it's for people to get started with Azure Machine Learning, and if you want to productionalize it, that's when it costs you money, but it doesn't cost you anything to learn. When you start getting charged is when you deploy it into a production environment and start running it a number of times. If you don't do that, you can continue to use it all the time. It is called Studio at Azure ML.net. And you can, one nice things that it does if you are trying to train your model is it integrates with Excel. So if you wanted to enter new data to see how that would work, it will go ahead and do that for you. It can automatically create a web service, and that web service can be used within the any pipeline that you want. And you can just call that web service, and it will run your component for you. And it contains a gallery containing many working samples. One of the things that I think is kind of interesting about the new product is the gallery is way smaller. Even if you do nothing else with this product, I think it's worthwhile checking out the gallery, because there's working code there that you can take a look at, and who doesn't want to look at working code? This is very similar to the visual interface, which they now call included within there. It's part of the preview edition, but it is a little bit different. So the differences between the 2 of them is the AML visual interface. That's part of your Azure subscription, and you need to select compute prior to running jobs. What this means, though, so for Visual Studio, you don't get to pick the compute. You have a whole bunch of different deployment options with the visual interface. With Studio, your deployment basically is create a web service and deploy the web service. And you can deploy that web service pretty much anywhere. So I'm going to go ahead and then take a look at that as well. So that is located here. So this is Studio at Azure ML.net, and you do need a Microsoft account to use the product. That's the only thing you need. So go to Outlook.com and create yourself one up. And once you have that, you can create your own experience. Let's take a look at some of the things that exists. If we look at this interface, you'll notice that it looks a whole lot like what we just looked at. And as a matter of fact, the items on the side are similar as well, but they actually have more algorithms. So if we look at the classification, there's a number more, they include a lot more algorithms than they have included in the new version, which is sort of interesting. But what I really like about this product is the gallery. So if you look at the gallery, it contains a whole bunch of different code that you can take a look at and use that actually works for doing different machine learning processes and tools. So it's got the data included within it. So if you wanted to take a look at, I don't know, customer churn, you can go ahead and click on a project, and it can just click on view. So, and it'll take you to where all the code is, and you can take a look at it. And oh, by the way, so you'll notice that I was sitting in Azure Machine Learning Studio. It brought me to GitHub, and where it's got Python code. So it's got a lot more code than just what you might see on the visual interface. So what I could do is open this up, maybe, and then I could take a look and run all of this code. Another thing that is contained within within Azure Machine Learning Studio, because everybody has to have it here, is it also contains a, and notice now they're calling this classic. That's cute. It also contains notebooks. So you could use this to create and run any notebooks you wanted to as well. So, I mean, because everybody needs another place to do Jupyter notebooks, there just aren't possibly enough of them around, but this would be another place that you can go through and run your Jupyter notebooks and create them within here as well. Where is the compute for this? The compute for this is basically created when you create the account, and it is non-configurable. So you get what you're given, basically, and it's kind of a black box. And there is quite a bit of variability in the amount of time that it takes to process something. I will also tell you that this will not handle large amounts of data. I had a customer that tried to put a terabyte worth of data through this, and it crashed every time. So I don't think you could handle more than, I don't know, like a couple hundred meg. But the idea is that this is not a place where you necessarily run this for real. This is where you are doing your testing and analysis. And the way it's set up, you're doing testing and analysis with a limited set of data because it cannot handle very large sets. And if you want to handle large sets, then you will need to pay for it because this is a 100% free tool. So one thing that's kind of nice about this particular environment, you also have the capability to upload data sets if you wish. So you could upload your own data sets and do all of your testing. I know a lot of people now are working on corporate machines that have kind of restrictions on how much information you can put on it in terms of loading all of this software on here. So if you do this is all cloud-based, and you can do all the compute, and you don't have to worry about any kind of machine that you happen to have. You don't have to load anything. And again, it costs you nothing. So, but this is now they're calling it Machine Learning Studio Classic. And you get to this particular product going to Studio at AzureML.net, which is, of course, a different place. So, any questions? Yeah. So your question was about the automated machine learning, how you could tell which algorithm was the best. Is there some kind of a leaderboard? There is not. But what you do have the option of doing is adding all of the algorithms that are available for that type of classification to your experiment, and then looking at which one performed best. I'm not sure I understood your question. Your question is, does it include what? Does it include ensemble models? No, it does not. Good question. No, it's kind of a little lightweight on that regard, but it is something that they're working on. Question? How is the collaboration in this space? So within Azure Machine Learning Studio, this particular application, with this particular application, I invite people. So I could invite anybody that I wanted to collaborate, unless they've taken that out. And then they could then look at my information that I wish to give to them. Now, if I'm in the other product, of course, that's through Azure. You can allocate as many users as you wish to a given ML workspace, and all of that is controlled within the security of your tenant. So this is not included with your Azure tenant. So it is completely outside of the tenant. So be mindful of that when you are logging into it, because I wasn't thinking about it, and I logged into it, and I was logged into my client's Azure tenant, and it automatically created a new account for me in this space. So, but you don't have to have this as part of any Azure tenant whatsoever. You can use a completely separate email. But watch it, because if you are connected to a different tenant, it'll create a new account for you using that tenant's information. So just keep that in mind. Any other questions? Yeah. Yes. Is it possible to import an Onyx format? If you have something that you have created that's already formatted as an Onyx component, yeah, you can import it. Yeah. Pardon? Is it the full feature set? Yeah, so the deal with Onyx is what Onyx does is it allows you to run your code in what's called like a virtual machine, really. So if you've got it in that component, it doesn't really matter where you wrote it. Because it's open source, you could have created a bunch of Python code on your Mac and then encapsulated that within Onyx, then put it up to Azure and then run it as part of ADF. So it's completely device agnostic where you create it. You could import it and then run it wherever. So the idea with that, though, is you are running it within the Azure environment, so it would be tracked, and they'd count the runs and how long it takes, and using the other tools that I showed you. But good question. But that is not within here. Within here, what I can do is I can create a web service. And if I create a web service, this web services can be called from within other Azure products. So this is obviously Gen 1, this tool came out, I believe, 4 years ago. So doesn't have the rich feature set. With addition, within Azure Machine Learning Studio, you also have notebooks. Within those notebooks, you can use R or Python. And you need to load the environment to see the notebooks. There's also a product called notebooks@azure.com. It uses the Azure account, but there is a free version of it available. And with that, you can use any language. And you can attach that to a data science VM. There's also Azure Machine Learning for Visual Studio Code. That's app components designed to assist in machine learning. And with that, you can use VS Code to create and deploy machine learning solutions. So you would deploy those to your ML Workspace. And that could be where you might write your Onyx code within code and then upload it there. Now this is sort of cheating, but I have seen Microsoft call VMs with SQL Server machine learning. They call that Azure because you can deploy it into the cloud. So this is just SQL Server, and it can use R, Python, or Java with 2019. Java does not configure in the install. You need to use the language extensions for that. And Anaconda is included as well. Microsoft has also added, this was talked about in the keynote, SQLDB for machine learning services, and this is in preview. This only contains R. And you can only write to global temporary tables, so it's kind of limited in what it can do. And you can't set the resource limits. They're fixed at 20%. So if you wanted to write machine learning within Azure SQL DB using R, that is now available, and it's talked about in the keynote. The other method that you might have for doing data science is using a virtual machine. Microsoft has created what they call data science VMs. And they are pre-configured for doing anything you might want to for machine learning, and you can use them to expand your local services. So basically, it's a server with a whole bunch of stuff loaded on it, so you don't have to. And the idea being is that you've got a controlled environment for creating these. And they have versions for Linux as well. The last tool that I wanted to talk about, which is a way to do machine learning in Azure, is using Databricks. Databricks is not a Microsoft tool. It is licensed by Microsoft to run in Azure. It also runs in AWS, so if you learn it and you change the clouds, it still works fine. So it's designed to use Apache Spark environment for creating machine learning experiments. So that's how you can use it to do machine learning in Azure. It's fully integrated with Azure Active Directory Security, so it is fully compliant with any of the security that you have in your tenant. So I wanted to go ahead and take a look at Databricks. So with Databricks, when you load it load it into a completely different environment. Creating it is relatively simple, but there is one catch, and I wanted to just briefly talk about that. If you want to use a lot of the very high-end services that are available with Databricks, you need to know which data centers have those services, because the highest end clusters are not available everywhere. They're only available in some of the data sets. So when I go ahead and the documentation they've written here is really pretty good. So if you have created a Databricks workspace, take a look at this information because it can be really helpful. You can notice here, you can also link this to your Azure ML Workspace. So if you do that, then you incorporate the runs that you're doing in here within the Azure ML Workspace that we looked at earlier. So you can incorporate within that as well. So if I go ahead and say Launch Workspace, notice here it's doing the Active Directory single sign-on. And it loads up in my it loads up in Azure, but it's a completely different environment. So within this environment, I can, of course, add people and do different security tasks. It also contains integrations with Azure DevOps and GitHub so that you can use source control to manage your code. But it primarily runs a version of Jupyter Notebooks. One of the things that I wanted to mention, the compute is also separate with Databricks, which is probably how Microsoft got the idea. The compute you have is runs on clusters, and you'll see that I don't even have all of mine running right now. You'll also see that I have automated clusters here. So if I've got a job running, which is running right now, what that is the cluster is spun up to run my particular job, and then it shuts back down. So I don't have to keep it up and running just to do something. When I create a cluster, one of the options that is really nice and I wish existed in other environments, and I'm going to go ahead and click on that, is you have this thing that says terminate after 120 minutes. Boy, I wish I would have done that if I was messing around with StretchDB. That like screwed up the weekend. But yeah, it'll automatically terminate. And honestly, most of the time I set this to 20. And the reason why is if I'm using it, it's not going to terminate. So it's basically, if after you've stopped using it, then it sits around for 2 hours and then turns off. So you can set this at 20 minutes and after you haven't touched it. And let's say you're like, and what happens when it's terminated? Nothing. You just get this little gray box and it says, oh, it's terminated. Sounds terrible, but it's not. But you need to have it running to be able to do anything. So what I have here is I have a Python analysis that I've done of fire department calls in San Francisco. So I've created some Python code to read that file in. I can read the file in not only from the environment within Databricks, but I can also read it from within Azure, so Blob Store, Azure DB. And then I'm going to take a look at the data within it and see if I can determine what are the indicators to determine how long it takes to get an fire engine to show up after it's been called. So I can go ahead and take a look at the call type and see most of these are medical instance. And then I can just take a look at selecting the data because within Databricks they have what's called magic commands, and I can just put the SQL in here and then take a look at it just as if it was SQL and just do some simple SQL on it. I also can do some things like that you can do in Azure SQL DB, so I can just do a bar chart, scatter chart, do some different analysis, or just go back to looking at the data for anything that I happen to have. And then, since I'm still doing SQL, I can just basically look at call type and average minutes. And I can see that if you are, if it's some kind of train incident, that takes a while. So kind of interesting analysis you can do. But then I'm going to do something that I do in Python a lot, which is, I'm looking at doing one-hot encoding. So I want to transform my data so that I pivot it, so that I can, do better analysis on it, because a lot of algorithms require this kind of data format. So basically, I've changed all these into Booleans. So it'll only have a 1 in there if that is the type of call that it is. And then I can take a look at, run this. Importing ML flow, and then take a look at doing some predictions so that I can see, what's the indicators are that are most likely going to determine why it is not doing. I don't know what that happened, but so I could take a look at doing the predictions. So this is also considered Azure machine learning because it's machine learning and it's in Azure. And I realize that's sort of a cheat, but that's one of the ways that Microsoft identifies it. So I wanted to include it as well, especially since you can incorporate this within your machine learning workspace, just like you can the other components, so that you have all of your machine learning modules running in one place so that they can be centrally managed. All right, in summary, we took a look at reviewing all of the machine learning products. We discussed the uses for each of them, discussed some various different deployment options, looked at some of the notebooks, and clarified what machine learning means in regards to Microsoft products. And I hope that you find that a little bit more clear when you're trying to look through it, because all these things are called Azure ML, and this is kind of the picture of how they really look. I wanted to just basically, plug session evaluations. Less than 4% of people actually do them, so, be part of the minority. And thank you very much. Does anybody have any questions? Yeah. Yeah, Azure Machine Learning Studio, if you have a lot of data in that, it will crash.
Would you be able to share what you ended up using instead of that?
At the time, this product wasn't available, so instead of using the terabyte worth of data, what I did was I cut the data way back, and then I created a web component, and I ran all the terabyte through it. So there's no way around the fact that that product does not allow you to put a lot of data in it. What you have to do is create a web service, and then you can put as much data as you want to. Oh, by the way, when you want to put as much data you want to, it's not free anymore. Because if you are limited in the amount of data you can put through a web service component and not have to pay. It's like 5,000 records. It's really kind of small. Any other questions? Well, thank you very much.